what affects charged particles moving through it, and also review the right-hand rule. So our learning goals and objectives are to know the Lorentz force for a charged particle and be able to apply it. The second is know how to use the right-hand rule to determine the direction of the Lorentz force. And the third is to know common scenarios where the force from the magnetic field is 0. Alright, so we will begin. The Lorentz force, just for a magnetic field, is a charged particle Q with velocity v crossed into the B field that it's moving through. That gives you the Lorentz force. Since it's a cross product, we can rewrite this as QVB. So V and B are the magnitude of each, and then we have the sine of the angle between them, theta. So what we should see instantly here is that for theta equal to 0 and for theta equal to 180 degrees, this force is going to be 0. So what this means is that if the charged particle is moving in the same direction or exactly 180 degrees, so either parallel or anti-parallel to the magnetic field, then the Lorentz force on that particle will be equal to 0. So let's go ahead and do an example. So we can have a magnetic field. So imagine that that was straight. These are all straight. Going from left to right, so that's the B field. We can have a charge Q in here, moving upwards with a velocity v. And now what we need to do is figure out the Lorentz force on it. So what we need to do is we need to use the right-hand rule. So we have to remember that the force from the magnetic field is QV crossed into B. Now, right-hand rule. First thing, we're going to take our right hand and point fingers in direction of velocity v. So you're going to take your right hand and you're going to point in the same direction as v. And you do that because v comes first here. This won't work out the same if you do it with v. So don't do it that way. I repeat, do not do it that way. The second is turn your palm to face v. So what you're going to do is you're going to take your right hand, still pointing the direction of v, but you're going to turn your wrist so that your palm will face towards B. And the third thing is close hand to point fingers in B field direction. So we're going to close our hand now. So we have our palm facing the B field. We're going to close our hand so that our fingers point the B field. So at this point we should have our palm facing towards the right, the back of our hand facing towards the left of the screen, and we're able to point our fingers in the direction of the B field. Okay. So now what we do is look where thumb points. So at this point we have our fingers still pointing the direction of B, our thumb is into the page. So what we can do is we can say that circle with an X through it, this is V cross B. So right now we figured out the direction of V cross B, but we need to remember that there's this charge Q in front of it. So this will be the direction if it's positive Q. So if this is positive Q, so say plus Q, then the direction of the magnetic force, or the Lorentz force, will be into the screen. And then if it is minus Q, then it will be out of the screen, coming right at you. Alright, so the idea here is that at the end, so you want to use the right hand rule in these steps to figure out V cross B, and then at this point you say, is the charge positive? And if it's positive, then you're done, you figured out the direction of the force. If it's negative, then you have to flip the direction. Alright, thank you very much.